Hello everyone. In the last module, you learned about different data types like discrete, continuous, nominal, and ordinal data types. In this module, you will learn about the p-value and how to calculate probabilities and normal distribution. P-value. Now, the world of healthcare research is full of the p-value. If you open any professional medical journal, any life sciences journal, you're going to find p-values everywhere. The calculations behind the p-value are actually quite complex. Now we know we're going to get into those kind of mathematics. A p-value less than 0.05, typically less than or equal to 0.05, is statistically significant. It indicates strong evidence against the null hypothesis, as there is less than a 5% probability the null is correct. Therefore, we reject the null hypothesis and accept the alternative hypothesis. P. Value interpretation. A p-value higher than 0.05, greater than 0.05, is not statistically significant and indicates strong evidence for the null hypothesis. This means we retain the null hypothesis and reject the alternative hypothesis. If the p-value is below your threshold of significance, typically a p-value lower than 0.05, you can reject the null hypothesis. But this does not mean that there is a 95% probability that the alternative hypothesis is true. The p-value is used to measure the significance of observational data. When researchers identify an apparent relationship between two variables, there is always a possibility that this correlation might be a coincidence. A p-value calculation helps determine if the observed relationship could arise as a result of chance. In this section, you learned about p-values and its usage to test hypothesis. In the next section, you will learn about the probability and its usage.